So, a really important thing to realize here is that I am not a Jedi Knight. I'm sorry to disappoint you. I'm sure you think that I have all sorts of superpowers, but that's not one of them. So I am not able to exert a force on the puck after it leaves my hand. I can only exert contact forces on the puck. And so since I'm not touching it, there cannot be a force on it by me. Similarly, friction is something that the floor would exert on the puck, but the whole point of an air puck is that it hovers above the floor. It doesn't touch the floor, and so there can't be any friction. And so the only possibility is A. Even though the puck is moving to the right, remember, things with no forces acting on them, or things with a vector sum of 0 of the forces, move at constant velocity. So there's no need for any horizontal force here to explain the motion. Motion doesn't need to be explained. Changes in motion need to be explained. So because we're not concerned with rotation, or in other words, we ignore the orientation of objects through the rest of this course, we can ignore what part of an object a force acts on. The reason is that no matter where a force acts on an object, it has the same effect on the translational motion of the object. Where it acts only affects the rotational motion. So remember this picture from the very first lecture in the course. I talked about the particle model, and this is why we're going to be able to use the particle model. In particular, we're going to use the center of mass as representing the position of objects, because no matter where on an object a force acts, it has the same effect on the translational motion of the center of mass. We'll eventually look at systems where there are many forces acting on often sets of objects, and so we need clear notations to be able to distinguish between all these forces, and hopefully that notation should help us with identifying forces. So we might include in our notation what type of force we're talking about, and the agent and target of the force, because often when you have several forces, they might be of the same type, and you need some other way of distinguishing them. Also, as usual, because forces are vectors, we need to be able to indicate components. So here's the system I'm going to use for labeling my forces. You don't have to follow my system, but I'd suggest this is a pretty good one and you might consider it. So I'll always indicate a force with an F to tell you that it's a force. And in the superscript, I'll indicate what type of force it is, either contact or field. If it's a contact force, I'll just put a C, and that's for all contact forces. You may have met normal forces and spring forces and so on in various other courses. I'm not going to make those distinctions very much because, as we'll see, they're rather arbitrary and artificial distinctions. However, for field forces, I will distinguish between them. So I'll use a G for a gravitational force, which is the main field force we'll deal with in this course. But in Phys 1204, I'll often be using E for electrical force, and so on. And it might seem strange to use a superscript because, that's exponentiation, but we'll never have to take a force to a power. And so that superscript spot is just sitting there unused otherwise. Then I'll indicate the agent of the force in the subscript and the target of the force. And in both cases, I'll just always set up a labeling system if I can, so I can indicate each of those with a single letter. And often I'll leave something out if I don't need it. So for example, I'll often be writing down a bunch of forces that are all on the same target, and then I'll just leave off the on part of my notation. Whether you are going to adopt my notation for forces or not, you do need to understand it because I'm going to be using it in the video lectures and during class. And so let's just make sure you can read my symbols. So let's think about two carts in the process of colliding with their magnetic ends. And so I have shown you a correct diagram of the forces acting on the right cart. That's cart 2. And so now I've told you the Earth is E, and cart 1 will be 1, and cart 2 will be 2, and the track will be T. So those are symbols I'm using to represent objects and targets. And now, according to the diagram I've drawn, what are the forces acting on cart 2?